Okay, here's the Pavlov game plan. I've got a data generation script. This is for generating a bunch of data. Color, elliptical vertical radii, elliptical horizontal radii, spin, depth, height. So we'll have time value, and then we'll have these other time is going to be linear upward, obviously. We can do like one of the horizontal radii be linear downward just for kicks. Spin can just be relatively binary and then have a half just to make it really obvious what it is. Height you can have the most fun with. We'll do different polynomial harmonic wave. Color I think it'd be really good for trigonometric, probably tangent shape, no reason not to. We'll just fit these in correlated with these other curves, but have a tangent curve generator. Radii vertical could be kind of fun to play with different logarithmic options. And cardioid is one of the most basic parametric functions, where you basically have radius and theta, some degree around, as your two parametric variables. So in a polar coordinate plane. And so that way we can start to think about parametric modeling in much more complex terms, not just with two variables. We're breaking down, really complex stuff into a single curve. And so that gives us good practice from just a basic science and math perspective, and it helps us generate these 7 columns of data. Whereas here, this is 2 columns, right? Time versus something, score. Time versus height, whatever. So these are 2 columns of data. We want 7 columns of geometric and color data in one plot. And then we want a bunch of plots to demonstrate exactly what's possible. I want to take a quick moment to clarify what I mean by 7 dimensions of geometric and color data. So right now you're seeing 2 dimensions where height is correlated with color, right? Color changes with height, and that makes sense. If we look at just one of these, this giant has a time value and a force value, but it's really just a column that has a certain height because of its force, and it's in a certain location because of its time. Right? Okay, so that's 2 dimensions, time versus force. Now if we have 7 dimensions, we can have data points. This is data points in 2D space, so we can have a 3rd dimension in the depth direction for where these things are located. The shape of it, instead of being a bar, can be like an ellipse. So here the ellipse is represented as a diamond, but you can imagine an ellipse and it has a vertical and a horizontal radius, and then that thing can be twisted into different directions. Okay, and I'll just bring this on home by reiterating, the point with Pavlov is we have a whole bunch of data files, and each data file has columns in it. In this case, they all have simply 2 columns of data, very basic, to make a scatter plot. So these are all those 2-dimensional scatter plots from all those files. These actually might not be the same files, but it's roughly the same idea, right? Each of these is a 2-dimensional scatter plot. Just list of numbers with a file name. Very easy. And so instead, let's say those files have 7 columns of data each. And can I show all of those all at once? And this is how we're going to exemplify that it's possible. That's the plan. So here's a quick list of different metrics, like what is the sensor sensing? The sensor could be sensing temperature, force, you could have rainfall data, elevation, latitude, longitude, or very obvious spatial. And then you can have cultural things like debt versus profit, violence versus cultural expression, positive, negative. But it's about narrative. You look at your data and you want to be able to understand the story. And so what do the numbers represent? And so when you look at it, you're not just seeing, hey, I see a curve. Great. What's the story? And so we need to connect these somehow to these curves. It doesn't have to just be these, but starting place.